Hello, this is lecture 26. 26, the second lecture of week 9. Okay, we are continuing the repeated game. I said the previous graph here, the dominant equilibrium, if Sarah and Jane play once, would have a different. Here, the only result is compete, 100. But if this game is repeated, there is a hope that they can move to collude, increasing their payoff to 200. However, let's think about the case where this game is repeated. The same game over and over, that's repeated game, is finitely repeated. Let's start with twice. So the previous game, T1 and T2, Sarah and Jane choose, and next period T2, Sarah and Jane choose again. By backward induction, in the second period, we remember we are dealing with a subgame perfect equilibrium. So in T1, the first period, Sarah and Jane should think about what would be happening in the second period. So we should know the second period in order to plan on the whole game in the first place, in the first period. In the second period, whatever happened in the first period, second period, the game ends. This is the final stage. And Sarah and Jane has no reason not to choose the dominant strategy, compete, because compete is always better than collude, because it is dominant strategy. So they will choose compete. As in T2, as you know, this is a prisoner dilemma kind of game. So this is for sure the dominant strategy would be played. Knowing that whatever happened in T1, Sarah and Jane will play compete, their dominant strategy in T2, the second period, final stage. This means the first stage is same as not repeated game, because as I told you, what we can expect the repeated game would be different from just playing once game. We call that one-shot game. So we have a one-shot game, and if we repeated that over and over, that is repeated game. Okay, the repeated means when you play when Mike play I don't know, Mike play with whom? Mike plays Sam over a long period of time. They don't have to play the same game over and over again. They may play different game. Today, rock, scissors, paper. Tomorrow, rolling the dice. After that, they have a running competition or something. But then, the repeated game means they do the same thing over and over again. Okay, something like that. But anyway, what's the difference between repeated game and one-shot game is, by repeating it, the players has chance to give a carrot or a stick. They make a promise today. If everybody keep the promise, they compensate each other. Okay? But if they betray, one of them betray, they move to punishment and hit each other with stick. So kind of revenge. I mean, I am a good guy. I will help you as long as you are faithful to me. But if you just betray me once, I'm gonna be a devil. I'm gonna chase you to the hell and give you a hell kind of thing. Okay, like a boyfriend girlfriend. As long as they are faithful to each other, they repeatedly date each other. But if they are faithful to each other, then they have a nice relationship. But then the boy date another girl not faithful, then wow, something like that. So this repeated game can be different from one-shot game because the players has chance to revenge or compensate because it has a future. But then in this game where the game is repeated just once, like 2 times repeated game, the second period is fixed. Whatever you do, in the second period you will compete and compete. So it's not possible to say, oh, Sarah, if you behave well in T1, I'll do something to you in T2, but if you behave badly in T1, I'll give you a hard time in T2, because in T2, whatever happened in T1, they will compete and compete. So, kind of incentive carrot and stick system does not work. So, it's same as basically one-shot game because it has no meaningful future. Like it cannot say, if you behave well, I'll do something in T2. If you don't behave well, I'll do something else in T2. Because T2, whatever you do, it's fixed. It's final stage. They play, compete. So the conclusion is, okay, think it over. The conclusion is, if the game is finitely repeated, we thought about 2, but what about 100 times? The 100th period, both Sarah and Jane will compete. What about 99th? It has no future. Actually, 100th is already fixed with one result. Also compete. So it breaks down. So as long, even though it's million times repeated, if you have the final stage, it kind of dominate back by backward induction, and the result will be same as compete forever. We can never achieve 200, just 100 forever if the game is repeated finitely. We are going to think that a little bit more later, but then at this moment, I'll just sidestep to explain a little bit about probably what you already know, the summation of infinite sequence. Let's say, to review it, let's say D is the value A plus delta square A plus like that. Usually the delta is the discount factor, which means today's $8, tomorrow's next year's $8, then delta A is the value of today's value of next year's $8 kind of thing. So if the next year, 3 years later, 4 years later, and things like that. Okay, get rid of these 2. I don't know where these 2 went in. They're like delta squared for A, no 2. Okay, typos. I'm sorry about that. And the next thing is, same thing as D, the whole value, but multiply by delta. Then delta here, delta become delta squared by 2, delta became delta squared by 3. Okay, this goes to, but anyway, you got the idea. Okay, so this delta minus D minus delta D would be only A, because everything cancels each other. Sorry about get rid of this and 2's, you get rid of that, then the same result. My God, what happened? But anyway, that's it. As a result, the original value D would be A over 1 minus delta. I think you know. Just remind you why the sum of all this would be A over 1 minus delta. Okay? You understand it? Then you remember it. In an infinitely repeated game, okay, now we gave up our hope that the result would be something different, to not compete forever if the game is finitely repeated. Now our only hope is infinitely repeated game. In this infinitely repeated game, if both people keep choosing compete, okay, their basically value is 100, 100, 100, 100. Why 300? I'm basically assuming Sarah and Jane said, oh, let's collude at first. But then Sarah betrayed. Then Sarah, instead of 200, get 300. Jane get upset. Then they begin to compete because Jane does not trust Sarah anymore. So she give up colluding. So both of them will compete. So Sarah deviate, cheat, and choose compete, and 300. Okay, Jane gets 0, but we are talking about Sarah. So 300, then 100 forever. Okay, then this would be it. 300 by cheating, deviating in the first period. Second period, now give up collusion, they compete. So on and on and on. Then it will be like this. Okay, using the summation of infinite sequence I showed you before. If Sarah decides colluding forever, she will get 200 forever. Of course, unless the Jane betray you, but let's assume that both will keep their promise and collude. 200, 200 delta, next year, next year, next year kind of thing. So 200 over 1 minus delta. Sarah would be wondering, should I deviate, betray, and get this 300 plus 100 delta over 1 minus delta, or should I keep the promise and get 200 over 1 minus delta? There's no answer for that because we do not know the delta. Everything depends on delta. So what is the condition that colluding payoff is bigger than competing, betraying, and competing payoff? Please calculate. It's not that difficult. 200 over 1 minus delta is bigger than or equal to 300 plus 100 delta over 1 minus delta. Then this condition holds if delta is bigger than or equal to half. Okay? That is infinitely repeated game. Okay? So what is delta? Delta is tomorrow's $1 value of today. So if from the T1 Sarah's point of view or Jane's point of view, tomorrow's $1 is at least as good as or better than today's $0.50. Okay, why it is important? If Sarah is really impatient person, it has something to do with patience. Sarah is supposed to get 200, but from Sarah's point of view, tomorrow is not so important. Today is really important. Kind of the marshmallow story. I do not care if you give me 2 marshmallows hour later. I want marshmallow, 1 marshmallow right now. Okay? Because tomorrow's 2 marshmallow is not as good as today's 1 marshmallow. Like, I can make a lot of money if I study very hard and suffer when I was young. Then you are not patient. So, if Sarah choose today's 300 instead of keep getting 200. So basically, if Sarah cheats and get 300, then 300 very good today, but 100 not so good forever. On the other hand, if Sarah keep choosing colluding, Sarah is not getting 100, only 200 today, but keep getting 200. So in order to choose 200 over 300 today, Sarah should have some value in the future. Today's big profit by deviating would not mean very much if Sarah think about tomorrow a lot. Okay, tomorrow and the day after tomorrow, I'm getting 100 instead of 200 forever. So cheating and getting 100 today is not so meaningful. On the other hand, if Sarah, for example, Sarah, the doctor says, Sarah, you are going to die tomorrow. Today is the last day of your life. Tomorrow's income would not matter. So Sarah has a very low delta, then she will definitely cheat. So in order to play a repeated game, the player should be patient, should have a value over the future, at least half of today's value. In this case, kind of weak. Then they will, Sarah and Jane, if their delta is bigger than y equal to half, they will choose the collusion. Okay, that is the case. Okay, this is kind of intuitive, makes sense, but we are formally learning subgame perfect equilibrium. So let's see if this can be translated as an equilibrium. We are going to talk about two stages, stage 1 and stage 2. Stage 1 is the equilibrium path. Sarah and Jane kind of promise to choose collude forever as long as nobody selects compete or deviate in the past. So if nobody deviate, nobody choose compete, everybody keep the promise to collude and charge $8, Sarah and Jane will keep choosing $8 and collude. That is stage 1. That is equilibrium path of subgame perfect equilibrium. This would be true only if nobody has reason to deviate. Of course, from the previous calculation, if Sarah and Jane's discount factor is more than half, this stage 1 is true. Choosing compete means 300, then 100, 100, 100. Instead, and Sarah and Jane, with delta bigger than half, will choose collude, collude, collude forever, because that gives them higher payoff. What is then stage 2? Because colluding give you better payoff than compete. Why? Because Sarah and Jane's delta is bigger than half. Then they would never choose compete. But then this is non-equilibrium path, stage 2. We have to mention the non-equilibrium path. Why? Because what happens in non-equilibrium path is the reason why they choose the stage 1, the equilibrium path. If anyone selects compete, even though nobody would select it, as long as their delta is half, but still, if anyone choose compete, then both Sarah and Jane will choose compete forever. Meaning this, if anyone choose compete and get 300, then they will choose compete, compete, and 100, 100, 100 forever. Okay, so this part is what stage 2 talking about. We call it a punishment page because Sarah and Jane promised if they are a good girl, they will choose collude, collude, collude forever. But the meaning that you are in the second stage means somebody betrayed. Either Sarah or Jane has been a bad girl. So then they should be punished. How? Here, in this game, if you collude Sarah and Jane, you are a good girl, so next period you'd be compensated by 200. But if you betray, you are a bad girl, you are getting 100. So if you are getting 200 instead of 300, Jane, you're a good girl, so next period Sarah will give you 200. But if Jane betray and get 300, then Sarah said, you are a bad girl, you will get 100. So 200 is carrot, 100 is a stick. And this system, carrot and stick, make both Sarah and Jane to collude forever. Okay? So that is an incentive system, carrot and stick. Okay? And here, one thing is, this game has two sub-games. Sarah and Jane can either, like in equilibrium path, keep playing colluding in stage 1, or Sarah and Jane choosing compete if it's a punishment page stage 2. Stage 2 is automatically like a Nash equilibrium. Subgame perfect equilibrium means backward induction, which means the subgame itself should be a Nash equilibrium, but it is because this repeated game has one obvious subgame perfect equilibrium, means Sarah and Jane compete forever. Okay? You repeat the dominant equilibrium of one-shot game over and over. Of course, that is subgame perfect equilibrium for sure. So that is subgame perfect equilibrium 1. Now we are subgame perfect equilibrium 2, where they can collude. But then, if they collude, if they betray, they do choose compete. But this punishment phase itself is subgame perfect equilibrium. It's a Nash equilibrium. Subgame perfect equilibrium is in every subgame, every possible future, whether it's equilibrium path or non-equilibrium path. The action chosen, the strategy of the players should be a Nash equilibrium. That is, so it should not be like empty threat. Nobody would believe. But if Sarah and Jane said, if you behave badly and cheat and choose compete, then we are going to choose compete forever. But compete is a dominant equilibrium of a one-shot game. So that itself is a Nash equilibrium, subgame perfect equilibrium. So this is credible. This is not empty. If they choose to compete, both Sarah and Jane will do it because it is dominant equilibrium. So stage 2 fits the criterion of subgame perfect equilibrium, because in this subgame, what they have promised would be a Nash equilibrium. Complicated, think it over. You're smart, you will understand. In stage 1, if they behave badly, then they go to stage 2. Stage 2 itself is a Nash equilibrium. What about stage 1? If they behave nicely, then they will collude again, which means they are playing the stage 1 again. But from this calculation, stage 1, the collusion is better than compete. So itself is a Nash equilibrium. So stage 1 repeatedly, it's a equilibrium path subgame. That itself is a Nash equilibrium. If they betray ever, then they move to stage 2, which is a non-equilibrium path, but itself is a Nash equilibrium. So every subgame of this whole equilibrium is a Nash equilibrium. That's why we call this a subgame perfect equilibrium. So every period a new subgame begins, and this new subgame would be either stage 1 or stage 2, but stage 1 and stage 2 are both Nash equilibrium, so the strategy composed of stage 1 and stage 2 would be a subgame perfect equilibrium. Okay? Complicated? You will think it over, you will understand. So as I said, here we can immediately see that the stage 2 is where compete would be chosen forever, is a Nash equilibrium. And stage 1 is where the players choosing collude, as long as nobody deviates, is also Nash equilibrium, as long as delta is bigger than or equal to half. So in this Nash equilibrium, this is very verbal, but this itself is a subgame perfect equilibrium strategy. Stage 1, stage 2, if you write it down, that is subgame perfect equilibrium. Here, the players play either stage 1 or stage 2, but both stage 1 and stage 2 are Nash equilibrium. Therefore, as a whole, this is a subgame perfect equilibrium. Okay? I'm not saying this is each concept. You are entitled to be confused a little bit. But if you think it over, take the lecture over again, in the case you're confused, you will understand. Okay, this has been a lecture 26, and see you in the lecture 27 very soon. Thank you.